I'm very proud to present Team 404 with their app, Vitaleaf.
Hi everyone, and thanks for joining us today. This afternoon we're going to be talking to you about our application, Vitaleaf. Vitaleaf is a plant management application which we developed for plant owners like ourselves to carefully manage and look after their plants. Our team is made up of Phil, John, Hafifa, Joe and myself, and we've worked together on this project for the past 2 weeks. The reason why we decided to develop this app is because many of us in the team actually own houseplants and we face the same struggles. It's not always easy to keep your plants healthy, and I for one am terrible at keeping them alive. We wanted to develop an app that would act as kind of like a helping hand for plant care, and Vitaleaf is made to do exactly that. With Vitaleaf's watering system, you can keep track of your plant's watering dates and when they are next due for a water top-up. With the search functionality, you can find out what types of conditions each specific plant needs. And with Vitaleaf plant recognition, if you take a photo of a plant, you can find out which species it is and what type of care is needed. During this 2-week period, we've worked closely on every aspect of the application. Alongside building the front end and the back end, we've worked on things like wireframing, branding, and also project management, all while following agile practices like Kanban, daily stand-ups, as well as some other practices like pair programming and TDD. I'm now going to hand you over to Phil, who's going to walk you through the functionality of the application.
So our app starts with an AWS Cognito login. Let's wait for that. So there's 2 ways that we can start adding plants to our database. Let's start with the obvious ones. Firstly, we can start searching through manually. So let's click to search for a new plant. So we can scroll through all the different categories of plants we've got using our carousel system. What have we got? Cacti, foliage? No, let's go. We've got a cacti. We can scroll through, see what we've got. And I think we've got a crown of thorns. Get some info about the plant, and then if you want to add the plant to your database, you can give it a quick nickname. And we can put it in. Once we've got our plant in our database, we get plant-specific info on watering and light details, and we can tell it when we've watered our plant. And it will tell us when we next need to water our plant, and we can turn on in-app notifications for our plant as well. The app also allows for searching, so it will search for common names and Latin names. So that brings up our bottle brush plant, which we can also add to our inventory with a nickname. Now we have 2 plants to water. One of the kind of specialties of our app is that we can identify a plant using image recognition. So we're going to have a nosy at Joe's flat. Let's have a look at his Swiss cheese plant. Takes a picture, and it gives us a probability of what our plant is. So our top result is our Swiss cheese plant. It was correct. We can also give that a nickname. Let's put it in the app. Off it goes. That's not the end. Okay. If we'd got to the end of the video, we could have also deleted plants from our database, as well as assigning our own images to our plant to personalize it. I'll now hand to Hafifa, who will talk about the tech stack.
Yes. Can you move to the next slide, please? Thank you. All right. Since the beginning of the project, we as a team wanted to be ambitious with our tech stack and make the right choices to achieve the overall project goals while also enhancing our own technical skill base. After initial spiking, we settled on DynamoDB as it allowed a more flexible data structure, which led to using further Amazon Web Services, including API Gateway, to host and set up our API endpoints, Cognito for user verification, which is directly linked to our user database, Amplify to link our front-end user creation to Cognito. The implementation of AWS S3 allowed us the ability to store user-uploaded images, and finally, AWS Lambda functions, which trigger integrations between the various services due to their natural integration. Since we were going for a mobile-only approach, we chose React Native as along with Expo It offers excellent cross-platform compatibility. The choice of TypeScript made for a more robust front-end development and also satisfied the team's desire to expand our language base. Over to Joe for more details on backend.
So one of the first big challenges we faced was finding all the data we needed. After a lot of Googling over the spiky phase of the project, we came to the conclusion that we were going to set up our own API using a variety of data sources. So for the plant care details, we used an API called Open Plant Book, which also included plant images needed as well. For more detailed plant descriptions and plant bios, we use the MediaWiki API, which source data from Wikipedia. And we also used a website called guidehouseplants.com, which was an online plant encyclopedia, which helped us to sort of marry up the botanical names and common names quite nicely. In addition to this, we also use an API called plant.id for the plant recognition functionality. So when a user has a plant image they want to identify, this image gets sent to plant.id, and with the results of plant.id, we send a list of names to our own API. For any matching results, we display the data that is stored in DynamoDB, so the information displayed to the user is consistent throughout the app. But overall, after the learning curve of AWS, we found the serverless management of the backend really useful in terms of being able to deploy quite quickly. We're able to make any on-the-go changes to endpoints quite hassle-free, and moving forward, we've got everything in place really to scale the app and grow the app quite nicely. So yeah, I'll hand over to John for the front end.
Thanks. I'd like to delve into front-end of React Native and Expo for mobile development. We use TypeScript for our choice because we want to control our environment. Its stricter rule set on static typing made us much more aware of our inputs and outputs. And after some initial difficulties, we found it really advantageous to the development of the app. One unfortunate stumbling block after succeeding with the camera roll and photo-taking capabilities was being unable to set up a function we wanted to have, which was the light sensor to measure lux, which would enable us to measure a light in an area and see if the plant data we got from our apps, or API, sorry, could match the position of the plant in the home. With the time we had, this additional tech need couldn't be added despite our attempts. With more time, we could overcome this, and indeed several other features could be added as well. Next slide, please. These including the addition of a time-lapse gallery, as the user images can be saved to the AWS bucket, and it returns only the most recent, but a time-lapse gallery of the plant over time would be nice to be able to see the plant from when you get it, as it grows over time, and show its lifespan. Integration of the calendar to our watering times, so we could get notifications and view upcoming events for watering will be ideal. And indeed, there's a few more on there which we wanted to do, which came up during development. We realized that these would be things we could add in from the data set we've achieved and would like to incorporate in more time. Thank you very much for listening.
All right. Cool.